Hello students, and welcome to section 7-1, Operations on Functions. We'll start off with arithmetic operations, and there's four main types that we're going to be taking a look at. The first of which is the sum, such that if we're adding f plus g of x or f of x plus g of x, you're simply going to be taking a full function in its entirety, f of x plus g of x. The same goes with the difference, where f minus g of x or f of x minus g of x, simply though we'll be subtracting a full function from another. The product is simply the product of both functions f and g, as you see, and then of course the quotient, the division of two functions f and g. Note that g of x cannot equal 0 when you're doing that operation. Alright, for example, it says find f plus g of x, f minus g of x, f times g, and then f divided by g of x. Given that f of x is this quadratic, x squared plus 3x minus 4, and g of x is this linear function, 3x minus 2. So as we proceed through, now in this particular case, the notes are pre-written. For the sake of time and being able to get in as much of the notes as I can, I'm going to scroll through and uncover some of those problems. I do sometimes also write the notes, as you know. Let's go ahead and scroll down, starting with f of x plus g of x, or f plus g of x. We're going to do the addition of functions. And that, of course, speaks to you adding, well, as it certainly looks, x squared plus 3x minus 4 plus 3x minus 2. Turns out that this will be as easy as simplifying by virtue of like terms, which I've underlined. Turns out that 3x and 3x are like terms, so I've underlined them as such, as are negative 4 and 2. So like terms, of course, add as such, so x squared. 3x plus 3x, of course, is 6x. Negative 4 minus 2, or negative 4 plus a negative 2, same thing, is negative 6. Final answer, x squared plus 6x minus 6. Subtracting two functions, f of x minus g of x. So we'll make sure that, as you can see in the steps below, we subtract. Now notice that there are parentheses around the second quantity, just like up above, parentheses around the second quantity. For subtraction purposes, you have to be more careful with the sign. So when you subtract, it's actually plus the opposite, so minus 3x and plus 2. And that's what I would do to make it simpler for you. And then, of course, you still have like terms to consider. In this case, 3x plus a negative 3x, or 3x minus 3x, and negative 4 plus 2. Those are your like terms, which in fact, if you add, end up looking like this. So x squared minus 2 as your final answer. We'll proceed again now, as you can see, with multiplication. Turns out f times g, or f of x times g of x. Turns out that you are going to be distributing, as you can see in multiplication of 3x minus 2 times each respective term on this quadratic trinomial, 3x times x squared, 3x times 3x, and 3x times negative 4, and negative 2, of course, also distributed 3 times. It ends up where in the first instance, x squared times the quantity 3x minus 2 looks like this, and then 3x times the quantity 3x minus 2, and then negative 4 times the quantity 3x minus 2. So they actually distributed, instead of the binomial to the trinomial, they took the individual trinomial terms and showed it as, again, this times that whole quantity, this times that whole quantity, and that third term times that whole quantity, as you see with that last product. We'll distribute, and there you have it in the next step. Please take a look at the like terms. So negative 2x squared, 9x squared, those are like terms, as are negative 6x and negative 12x. And in turn, 3x cubed plus 7x squared minus 18x, and then of course plus 8 as your final cubic polynomial. Last but not least, division. Division sometimes ends up being the hardest of all, simply because you have more work to do usually on the simplification end of things. Plus, keep in mind you can't divide by 0, so there possibly may be extra steps warranted when it comes to identifying what does and maybe doesn't work in context. We'll talk about that more later, but just kind of keep you aware of how the quotient operation impacts various problems. All right, so we're going to go ahead and write it as the quotient. As you can see, they've done that for you. So the numerator is simply f of x, x squared plus 3x minus 4. Well, the denominator, of course, is g of x, 3x minus 2. So speaking of the nuances as to what maybe you can and I guess can't have, in this case, they say that x can't be 2/3. And the reason is because, remember, if this whole denominator is equal to 0, you have an undefined fraction. So we have to limit x values such that they can't equal 2/3. In other words, if you set 3x minus 2 equal to 0, setting it equal to 0, of course, gives you 2/3, and of course 2/3 will not be plausible. If you plug in 2/3, you get 0. So x can't equal this. One thing that I do ask that you continue with on a problem of this nature, if it's possible, and that is to factor. So I did the extra math, as you can see here, of which you can see my factoring take shape. So x plus 4, x minus 1, that's the factored version of the numerator, while 3x minus 2, of course, is still the denominator. X still can't be 2/3, so make sure you still make that notation. And I've also shown my work as such. So 3x minus 2, because it can't be equal to 0, of course, x can't be equal to 2/3 still. Okay, so let's move on. I'm not going to do every single problem, but I will do enough to kind of get the basic idea across and of course to continue. So we're going to do all 4 operations. Let's do number 1 together. Number 1, it is 8x minus 3 and 4x plus 5. With f plus g, or f of x plus g of x, you can see my analysis. Okay, so I've got the addition. So we've got 8x plus 4x, that's 12x. And yes, you can also see the product. We'll get to that in a moment. But also what? Negative 3 plus 5, which of course simply is 2. So f plus g, that's simple enough. What about f minus g? Well, be careful. When you're doing subtraction, please be careful with the second quantity in parentheses. I always recommend it be placed in parentheses so that when you do 8x minus 4x, remember, if this is in parentheses, you're adding the opposite. So 8x plus a negative 4x, technically, of course, is 4x. And negative 3 plus a negative 5, or negative 3 minus 5, still is, of course, negative 8. All right, let's take a look and see my math here with the product and also the quotient. The product is you simply rewriting this as a binomial times a binomial. So foiling first, 8x times 4x, 32x squared. Outside 8x times 5, which is 40x, and then minus 12x, which is the inside, right? 40 minus 12 being 28, 28x. And then last, negative 3 times 5, so negative 15. So foiling ends up looking, and you can see there, like we've done in the past, giving us this quadratic trinomial. The foiling ends up, as usual, ending up as such. When you do the division, the quotient, of course, of 8x minus 3 in the numerator by 4x plus 5 in the denominator, there's really nothing more that can be done here in the sense of simplification. So this is really all you need as a final answer. I wouldn't cross anything off because technically you can't. This binomial is separate from that binomial. The denominator, on the other hand, I do need you to write down that, remember again, because you can't divide by 0, x cannot equal negative 5/4 by virtue of, again, 4x plus 5 technically not being equal to 0. And I went ahead and I continued down below. X, again, can't be negative 5/4. So if you make that the denotation, you're also ensuring that the answer makes sense in context. In other words, x can't be a specific value. Okay, I'm going to go ahead and do a couple more here. I think number 5 in particular. I'm going to uncover the work there for number 3, which I do want you to try on your own. But I am going to go ahead and just kind of skip ahead, though, to number 5, because there is a lot of work involved with number 5, particularly because on number 5, if you take a look, we've got an f of x, which is x squared minus 1, and a g of x, which is 1 over x plus 1. So if we do the addition of terms, or functions, pardon, and the like terms as such will take shape. When you add x squared minus 1 plus 1 over x plus 1, there is the concept of getting a common denominator that needs to take place or take shape, which I've denoted here off to the left. So x plus 1 is in fact the common denominator. Here's the problem, right? This fraction is the only part of the problem that you're noting that denominator. So you have to incorporate with x plus 1 times x minus 1, remember as the factored form of x squared minus 1, you have to incorporate this as a fraction. You're multiplying really this whole thing times x plus 1 over x plus 1. It'd be like getting a common denominator on any fraction, multiplying by, let's say, 3 over 3, if you're getting a common denominator of 3. So that nicely takes shape now where these two are the same, so that then, as it turns out, you can multiply these three binomials and then add your numerators with that single denominator of x plus 1. So let me go ahead and scroll down here so you can kind of see where I'm headed with this. So you, again, like I said, have x plus 1 quantity squared as these two are multiplied, x minus 1, and then the 1 here is added there off to the side in the numerator. And it is one big numerator technically with this single denominator. As it turns out, this right here is a nice final answer, although there's a little bit more maybe to be done where x again can't be negative 1. Please note that. I wrote off to the right and down below in blue a little bit more, as you can see, simplification. So actually, if you were to take this quantity and simplify it, you do actually end up having a more simplified version where this plus that, by the way, simplifying it is initially what we saw at the beginning. So maybe this is not really a simplified version as much as it is what the answer key speaks to. This answer actually in blue is not as simplified in my opinion as this. Okay, this is a better answer. But now that I reflect, this is actually the book's answer. So just take a look and see how these two compare. And again, as it shows, just like I did here, x must be limited to all values except negative 1. Okay, subtraction is similar, and I'm going to go ahead and just uncover it for the sake of quick argument. It does show in my answer very much like what you see here. In my answer, a single fraction with x limited. And here's the answer in the book in blue. Okay, I would ask though that you write your answer as this when you simplify it fully. But this is of course something you'll see in the answer key. When it comes to multiplication here and division there, this is the product process. If we multiply x plus 1, x minus 1 times 1 over x plus 1, nicely these two factors divide. So you're simply left with x minus 1. And you still need to denote, even though these canceled here and here, you need to still denote back from the beginning what x can't technically be equal to. X can't be negative 1 again. So your final answer, when it's all said and done, looks like this. It does look odd, though, that the answer doesn't have a denominator that's a variable. It doesn't have a denominator at all, except I guess you could write it as over 1, but you still need to denote this nonetheless. The version or the operation here and the version that you see as far as this answer goes, this is the final answer for division. What you see here is the x plus 1 times x minus 1 product of the reciprocal x plus 1 over 1. Well, remember, the original g of x was 1 over x plus 1. If you take its reciprocal, remember, dividing by something is the same as multiplying by its reciprocal. So I'm literally just going to now multiply these three quantities, of which you see x plus 1 quantity squared. Not surprisingly, because that's what that entails. And I would be fine with that as a final answer, by the way, partly with this last factor included. So x minus 1 multiplied by x plus 1 squared. And gee, look at this. X again can't equal negative 1. This is a final touch to these types of questions wherein you're highlighting the fact that x can't be negative 1 from the very beginning. The very beginning, g of x is limited to all values except negative 1. As far as the next page goes, this will be part 2 of our lesson live, so please look out for that, but I do want you to try out tonight's homework for sure.